Alright, here are the Unit 2, Section 2.4 examples. So, exponent laws. Let's go over our first exponent law from this lesson. Exponent law for a product of powers. To multiply powers with the same base, add the exponents. So as we see, a to the m times a to the n is equal to a to the m plus n. The variable a is any integer except for 0, so that can be any number that doesn't equal 0. So it can be negative, positive, fraction, non-fraction. The variables m and n are any whole number. This means they can be any number that does not have a fractional part. So they can be a negative whole number or a positive whole number. For example, 1, 2, 3, -1, -2, -3. So let's look at an example. 7 squared times 7 cubed is equal to 7 times 7 times 7 times 7 times 7. But as we remember from elementary school and order of operations, if we have continuous multiplication, we can remove the brackets or the parentheses and have just 7 times 7 times 7 times 7 times 7, which is equal to 7 to the power of 5. Or 7 squared plus 3, which gives us 16,807. Let's look at the next example. Eight to the 4 times 8 to the 3 times 8 to the power of 1, because we know that any integer written as itself is to the power of 1. And as we examined in the last slide, if we have the same base, which we do, we have 8, 8, and 8, we just add the exponents. So we have 8 to the 4 plus 3 plus 1. This is equal to 8 to the power of 9, which is equal to 8 times 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 8. This is equal to 134,217,728. So the next exponent law for quotient of powers. To divide powers with the same base, subtract the exponents. So if we have a to the m divided by a to the n, it is equal to a to the m minus n. But remember that m has to be greater than or equal to n. Why does the number that m represents have to be greater than the number or equal to the number that n represents? Because if it is not, we'll get a negative exponent, and right now we don't want to deal with negative exponents. And as we said in the last exponent law, a is any integer except for 0, so it can be a fraction or a whole positive number or a negative positive number. M and m are any whole number, so this means they're not fractions or decimals. They are whole numbers, for example, 1, 2, -1, -2. So let's look at an example. 7 cubed divided by 7 squared is equal to 7 times 7 times 7 divided by 7 times 7. This gives us 343 divided by 49, which gives us 7. We know that 7 can also be written as 7 to the power of 1. If we look at our original question, 3 minus 2 is 1. So we know that we can write the original expression, so 7 cubed divided by 7 squared, as 7 to the power of 3 minus 2, which will give us 7 to the 1, or 7. So let's look at another example. 8 to the power of 4 divided by 8 to the power of 3 divided by 8. This is equal to 8 to the 4 minus 3 minus 1, or 8 to the power of 0, because 4 minus 3 is equal to 1, and 1 minus 1 is equal to 0. And we know that all integers to the power of 0 is equal to 1. Now you give it a try. 3 squared times 3 to the 4th divided by 3 to the 3rd. Alright, so step 1. Let's expand all the powers. So we get 3 times 3 multiplied by 3 times 3 times 3 times 3 divided by 3 times 3 times 3. Now if we group, this gives us 3 to the power of 2 plus 4, because we know from our first exponent law, if we have multiplication, we add the exponents, divided by 3 to the power of 3. So we have 3 to the 6th divided by 3 to the power of 3. And again, using our second exponent law, when we have two powers with the same base, we just subtract the exponents. So we get 3 to the power of 6 minus 3, which gives us 3 to the power of 3, which is equal to 27.